Hi, this is Kuba from RPA. A few weeks ago, I found and tried myself in RPA challenge. There have been few new ones released lately. I'm taking a closer look into one of these, shortest path. It seems to be really fun. Authors want challenges to do attended bot, but I decided to do it in unattended mode as it is simply doable. Goal of the exercise, in short summary, is to match pairs of balloons on the map, each red with closest green. Then read data shown below the map, fill the form with the data and submit. Difficulty here is data table rows comes in random order and most of row headers are images with text and noise. It is not that easy to read it and match with corresponding field on the form. I did it using two different ways, with and without OCR. The one with no OCR is much faster, around 7 to 8 seconds for entire exercise. For OCR I used Tesseract OCR and it took around 40 seconds for the entire cycle. The final time is not that important though, as both methods require few tricks to make them work well, and this is much more interesting here. Let me share the details. Let me first describe how we can make bot to select points, balloons, on the map in unattended mode. Aim is to select red balloon, demand, with closest green one, supply. For human operator that's no problem unless points are too close to each other. Bot needs to do some calculation though. One possible way to do this is to locate image position on the screen and then calculate distances. However, not all balloons are visible without scrolling the map. Let's see what's the code behind them. This highlighted CSS function moves the object in three-dimensional space. Pixel numbers are reposition vector coordinates, x, y, z. Third dimension is not used here, always 0 pixels, so assuming we have x and y coordinates now. We can calculate the distances between the balloons using Pythagorean theorem and choose shortest distances. x1, y1, x2, y2 are coordinates of respectively balloons 1 and 2. C is the distance we're looking for, and A and B are two remaining sides of the right triangle, with C as hypotenuse. So A equals x2 minus x1, B equals y2 minus y1, therefore C equals square root of x2 minus x1 squared plus y2 minus y1 squared. Here's Python code for that. Function takes red balloon we're looking to find a pair for and list of all green balloons as arguments. It calculates distances between red balloon and all green balloons, choosing smallest value and returning green balloon object. Now reading text from images. So what's the challenge here? Most of the details headers are noised images with text. To properly find out which detail is in a row, we need to read text from image. But is this necessarily required? So we need to be clever. We have everything we need to correctly capture, or rather to do an educated guess, what is represented in each table row. How? Through data analysis. So let me show you that. So first of all, ship preference. Can be only 3 values, enclosed, flatbed or steep deck. So wherever we see that values, we know that this is a ship preference. Then cargo preference can be 2 values only, RJET or permit required. State, that's string 2 characters, non-numerical. Then zip code, 5 characters, last character is always numerical. Demand date, 10 characters, third and sixth is dash, and remaining characters are numerical. Address 2 you can find in balloon pop-up. So what remained? Address 1, city and cargo remained, with no clear rules as stated before. What to do now? Assuming that the noise on images is random and knowing the texts are different in characters length, we can try to see what's the average color of an image. Presumably address 1 will be darker than city. Another trick here is the images are provided to web pages base64 encoded data, so we need to decode that. Results of the exercise are promising. City image min is in range 1.2 to 1.75, cargo image mean in range 1.75 to 2.17, and address 1 in around 2.17 to 3. Important to mention that address to image mean is very similar to address 1, so we need to exclude it. This way we have complete set of rules to assign our variables. We can treat supply data similarly. So that's the method 1. So the second approach, as I mentioned, is to read image with OCR. I used Tesseract OCR, as it is first of all free and secondly considered best among free OCRs. I already mentioned that images have, apart of text, plenty of random noise, therefore OCR didn't initially return good results. What we can do about it? We can denoise the image. Results are not stunning, but enough to improve Tesseract hit rate. However, this is still not it. Some results are distorted, so we receive slate or .stale instead of state. So we need to work it out. There is a method to measure distance between words numerically. It is called Levenstein distance or edit distance, and we can use it easily in Python. Here's full code for text recognition. What are the method results? So the good thing about RPA challenge or challenges is that you can do it as many times as you want, and secondly it shows you the rating. Having scripts for both methods, I checked how accurate are they. The scripts performed 100 times, so that means updating 8000 fields, and the result is as follows. Method with no OCR missed to find out correctly 204 times out of 8000 updated fields, so this means accuracy 97.45%. And Tesseract OCR supported by denoising and Levenstein distance missed only 16 times out of 8000 fields, meaning accuracy 99.8. Both results are pretty good, but I believe there's still plenty to improve and 100% is in the reach. Now's the time to update the fields, the form fields. Once I have all the contract data assigned to variables, I inject JavaScript to the page. So I won't be describing this method here, you can find it in my previous video. This challenge of course is not real life scenario, but it includes elements you may approach on your RPA way, so this is a really nice way to train yourself and train your methods. I'm encouraging you to give this and the previous challenge a try. Thank you and see you next time.